Okay, this is lesson 3-3, function notation. Okay, so the first thing we're going to start out with is evaluating a function on example 1. It says evaluate f of x equals negative 4x plus 7. So I first want to start out with when you see this. F of x, or g of x, or h of x, that's how you say that, f of x. That is the same thing as just saying y. Like y equals, it doesn't change anything. It says this is the exact same thing as if they had wrote y equals negative 4x plus 7. Okay, so don't let that f of x throw you. It just means function notation. That's just when you hear function notation, it's going to be written with an f for function instead of y. So when it says evaluate this, when x equals 2 and x equals negative 2, you're just plugging in x is 2 and solving, then plugging in x is negative 2 and solving. So that doesn't mean you're solving anything on this side. They're just showing you that now for x, they're going to plug into 2. This is the same thing as saying y equals. You're just dropping that side basically. So on this side, I have negative 4x plus 7. Well, x is now 2. So I replace that with a 2, which means negative 4 times 2 plus 7. Negative 4 times 2 is negative 8. Negative 8 plus 7 is negative 1. That is your answer. You're not doing anything on this side. It just stays f of x or f of 2 the whole time. So when x is 2, f of x will equal negative 1. Now we have to solve for when x is negative 2. So again, we're just plugging that in for x. Don't worry about this side. So negative 4 times negative 2. Negative 4 times negative 2 is positive 8. And then we still have that plus 7. 8 plus 7 is 15. So when x is negative 2, f of x will be 15. Those are your answers. Okay, now let's look at interpreting function notation. So it says, let f of t, so it could be x, t, let f of t, or y, be the outside temperature in Fahrenheit, in degrees Fahrenheit, t hours after 6 a.m. So y in this case represents the outside temperature. T represents the amount of hours after 6 a.m. Explain the meaning of each statement. So on this first one, A, f of 0 equals 58. So f of 0 means 0 for t, so 0 amount of hours after 6 a.m. So that would mean exactly at 6 a.m. So on A, they're just asking us if we can interpret this in terms of the problem. So for A, f of 0, that means when the temperature is at when it is 6 a.m., the temperature is 58 degrees Fahrenheit. That's all that means, because 0 means 0 hours after 6 a.m. So then on B, f of 6 equals n. Well, 6 in here means 6 hours after 6 a.m. So we have 7, 8, 9, 10, 11, 12. So 12, okay? So at 12 o'clock or at noon, the temperature would be in degrees. Just means they don't know, some number. That one sounds kind of weird because it's not a number, but it would just be in. So on C, this one looks confusing to me. These are the easiest ones once you plug it in. So f of 3, first let's figure that out. That means 3 hours after 6 a.m., 7, 8, 9 a.m., so that means 9 a.m. And 9 hours after 6 a.m., so 7, 8, 9, 10, 11, 12, 1, 2, 3 p.m. So all this would mean is the temperature at 9 a.m. is less than the temperature at 3 p.m. You're just having to interpret that. Okay, so based on those two examples, let me move this. I want you to try 1 and 2, because it says evaluate the function when x equals negative 4, 0, and 3. So you're plugging those numbers in for x. Then on 3, it says in example 2, let f of t be the outside temperature in degrees Fahrenheit, t hours after 9 a.m. So now we're looking at 9 a.m. Explain the meaning of each statement. On this part, I want you to do A, C, and D. You're not going to worry about B. So do A, C, and D. So do 1 and 2, and then do 3A, 3C, 3D. Pause the video, and then I will go over them with you. Okay, on 1 and 2, we are solving for values of x, negative 4, 0, and 3. So on 1, we have f of x equals 2x minus 5. So f of negative 4 just means you take and plug negative 4 in for x. So 2 times negative 4 is negative 8 minus 5. Negative 8 minus 5 more. So f of negative 4 is negative 13. There's one value, so we'll have 3 answers on each of these. F of 0, plug 0 in, 2 times 0 is 0, so that equals negative 5. That one should have been pretty easy. And last one for value of 3. So we have 2 times 3 minus 5. 2 times 3 is 6. 6 minus 5 is 1. Sorry, I wrote it twice. So on number 1, our answers come out to negative 13, negative 5, and 1. On number 2, we're plugging in the same functions now for g. So the first one, g of negative 4, would be negative. Then we have negative 4 squared minus 1. Sorry, I didn't do a very good job on writing that. Let me rewrite that for you. So that negative out front stays out front. Then I have negative 4 squared minus 1. So negative 4 squared, 4 times 4, or negative 4 times negative 4 is positive 16, but there's still a negative out here. So negative 16 minus 1. Negative 16 minus 1 more is negative 17. That double negative kind of threw us. So g of 0, the reason it stayed out front is because that negative was already there. We were plugging in a negative 4 for x, so they were both there. So 0 times 0 is just 0, minus 1 is negative 1. And the last one, when we plug in 3, that negative stays there. 3 squared, 3 times 3 is 9. There is a negative there, so it is negative 9 minus 1 more. So g of 3 is negative 10. So for number 2, we got the values negative 17, negative 1, and negative 10. Maybe you can see it a little better. There we go. Sorry about that. Okay, last one on 3. We did not do B. We did A, C, and D. It was referring to, I can't remember the initial problem, but something about it started at 9 a.m. We're talking about temperature. So this one says f of 4 equals 75. We're just having to interpret what that means. F of 4 would mean 4 hours past 9 a.m. So we have 10, 11, 12 a.m. or p.m., then 1 p.m. So what that means is at 1 p.m., the temperature would be 75 degrees Fahrenheit. That's all that means. On C, f of 2 equals 9, so 2 hours past, so 10, 11 a.m. The temp is 9 degrees Fahrenheit. It's pretty odd, but that's what it says. Okay, then the last one with the inequality sign on D. What that means, first let's calculate what these numbers are. 6, so we have 9, 10, 11, 12, 1, 2, 3, so 3 p.m. So the temperature at 3 p.m. is greater than the temperature at, and since it says 0, that means it didn't go anywhere, so it would just stay 9 a.m. So the temperature at 3 p.m. is greater than the temperature at 9 a.m. Okay, now we are going to use function notation to solve and graph. So remember, anytime you see h of x, f of x, g of t, any of those, it's just another way. It's called function notation to write y equals. It is still just an equation. So this says, for h of x equals negative 2/3 x minus 5. That is your equation. Find the value of x for which h of x equals negative 7. So that's the same thing as them saying solve for x if y equals negative 7. You're just going to take and set the whole thing equal to this. So you're going to replace h of x, or your y, with negative 7 and solve for x. So this becomes our new equation right here. Negative 7 equals 2/3 x minus 5. Now you are just solving for x. So the first thing we do is we get rid of this 5. It's being subtracted, so you add it on both sides. Negative 7 plus 5 is negative 2. And we're left with 2/3 x on this side. Now, Those are being multiplied, so we would divide, but we can't divide a fraction by a fraction, so we flip it, 3 over 2, and multiply both sides by that. So over here, this cancels, and I'm left with x, which is what we wanted. Over here, this one actually works out nicely, because technically that's over 1, so these 2's actually cancel, and you just have 3 times negative 1. Or if you plug in the calculator, you'll see that 3 times negative 1 is negative 3. So x equals negative 3 when the h of x was negative 7. So this is your answer. You don't have to tell me the other. It would just be x equals negative 3. Now let's look at example 4. Let me erase this stuff. Okay, so now we're going to look at graphing these linear functions. Now, they are linear. That already tells us it will make a straight line. So if we go to graph this and we don't get a straight line, we know we messed up somewhere. Okay, so on this one, graph f of x equals 2x plus 5. Same thing as y equals. What you're going to want to do is make a table. So they made a table this way. I honestly think it will be easier on us to do our tables like this. X here, y, or f of x here. And then your rule goes in the middle. So on this problem in the middle, I would have 2x plus 5. Then you're plugging in your numbers. Now, they plugged in negative 2, negative 1, 0, 1, 2 for x. I suggest just using those same numbers because you've got 0 in the middle, a few negatives, and a few positives. So all you do is you take those numbers. Remember, your domain is given, or you get to choose those values. Then you are just plugging them in for x. So here we would have 2 times negative 2, which is negative 4, plus 5. Negative 4 plus 5 is positive 1. That's how they got 1 here for your y. Then you would do the same thing for negative 1. 2 times negative 1 is negative 2. Plus 5, negative 2 plus 5 is positive 3. That's where they got this 3. And you would just keep going till you get all of those numbers. Now, once you've done that, you have your x and your y, which are points on a graph. So right here, this is the point negative 2, 1. So when you make your graph, you're actually going to graph the points that you find from your table. So you will have 5 points to graph. Once you graph your points, draw a straight line through them. They should make a straight line because it is a linear function. And then, bam, you've graphed your function. So the point negative 2, 1, we go over 2, up 1. The point negative 1, 3, left 1, up 3. Okay, so that is how you graph it. So let's see. So I want you to do all 5 of these, 4, 5, 6, 7, and 8. So 4 and 5, you are just finding x. You're solving for x for the given value. So number 4, this says f of x equals 6x plus 9. So you're solving for x on that when f of x equals 21. So on 4 and 5, you're doing that. On 6, 7, and 8, you are graphing the linear function like we did right here. So pause the video, try those, and I will go over them with you. Okay, I'll start with 4 and 5, and then I'll erase it and do 6, 7, 8. So on 4, we have f of x equals 6x plus 9. So we are solving for when f of x equals 21. So what we do is we set it equal to 21, and we solve for x. We're trying to determine what does x need to be for this function to equal 21. So I solve for x. So I would subtract 9 from both sides. I get 12 equals 6x. Again, to get x by itself, I would split these apart and divide both sides by 6. We get that x would equal 2. Okay, on number 5, g of x equals negative 1/2 x plus 3. And we're going to solve what would x need to be for g of x to equal negative 1. So I'm setting the entire thing equal to negative 1. So the first thing we would do is subtract 3 from both sides. Negative 1 minus 3 more is negative 4. Now, this is being multiplied, so we would divide, but it's a fraction. We can't divide a fraction by a fraction, so we flip it and multiply both sides by negative 2 over 1, which really means we're just multiplying by negative 2. Negative 2 times negative 4 is positive 8. So x equals 8 on that. All right, on 6, 7, and 8, we are graphing these linear equations. So they're all already in the correct form. So the first thing I suggest you do is make a table. Plug in some domain values. So you can either do a table across or up and down. So on this problem, my rule is 3x minus 2. So I'm going to do negative 2, negative 1, 0, 1, and 2. Table doesn't have to be fancy. Okay, so here I would have 3. My x is now negative 2, so I replace it with negative 2. So that means 3 times negative 2, which is negative 6, minus 2 more is negative 8. Here, x is negative 1. So 3 times negative 1 is negative 3, minus 2 more is negative 5. 3 times 0 is just 0, minus 2 more is negative 2. 3 times 1 is 3, minus 2 is 1. And 3 times 2 is 6, minus 2 is 4. So those are your points, your x and y values. This is the point, negative 2, negative 8, negative 1, negative 5. So we would go and graph those now. Okay, so my first point, negative 2, negative 8. So I would go left 2, down 8. My next point, negative 1, negative 5. 0, negative 2. 1, 1, and 2, 4. I accidentally spaced a little bit of mine out because it should make a straight line. My lines were spaced out a little off, but it for the most part makes a straight line and you can at least see what it should look like. Okay, on number 7, g of x equals a negative x plus 4. So if I make my table, kind of scrunched that one a bit. This table got smaller. Sorry about that if you can't read it. Okay, so here, don't let this confuse you. That's a negative out front, then your x. So negative times a negative is positive, so that is 2 plus 4, which is 6. So on this one, those cancel, and it's 1 plus 4, which is 5. 0 can't be positive or negative, so a negative times 0 is just 0, plus 4 is 4. So negative 1 plus 4 is 3, and negative 2 plus 4 is 2. Okay, so this is the point negative 2, 6. As if it were like that, x is first, then your y. So negative 2, 6, negative 1, 5, 0, 4, 1, 3, 2, 2. We have our linear function. Okay, last one, problem, I'll let you see a little better. Problem number 8, we have h of x equals a negative 3/4 x minus 1. Let me see if I can do a little bit better table here. So this one, my rule is negative 3 over 4 times x minus 1. Okay, so I have negative 3 over 4 times 2 minus 1. Plug that in the calculator to double check. Yeah, so we get negative 1.5, and then minus 1 more, so negative 2.5. I'm going to keep on decimals just because to me it's easier to graph a point when it's a decimal. 3/4 is the same thing as 0.75. Oh, whoops, I messed up, didn't I? I left a negative out right there. A negative times a negative was positive 1.5 minus 1. I thought I got 0.5 earlier. Sorry, y'all. That is just 0.5 because negative times a negative cancel. I forgot to plug my negative in. So negative 3/4 times negative 1. We get 0.75. I had a brain fart. Duh, anything times 1 is itself. 0.75 minus 1 would be, negative 0.25. So on this one, that cancels because it's times 0. Minus 1 is negative 1. Negative 3/4 times 1 is negative 3/4, or negative 0.75 minus 1 more. Negative 1.75. And then negative 3/4 times 2 minus 1 more. Negative 2.5. Yeah, because that's what I accidentally got up there because I plugged it in wrong. Okay, so now we can graph this. Trying to space it out a little so we can see our decimals a little better. So this first point, negative 2 and 0.5, so I would go over to negative 2. 0.5 is between 0 and 1. So then I have negative 1, negative 0.25. Halfway would be 0.5, so it's half of half. 0, negative 1. 1, negative 1.75, so it's almost to 2, negative 2. And then 2, negative 2.5. So it still makes a straight line, they just don't go very far.